Hello and welcome to the Controller Talk podcast presented by Danfoss North America. Our goal is to bring you information about using Danfoss controls in the supermarket and warehouse industry, specifically in the US and Canada. We're doing these twice a month for now. You can catch these podcasts wherever you get your podcasts, and it's also available through the Danfoss Ref Tools app. For the video version, check us out on the Danfoss North America YouTube page. Search for Controller Talk to see our video collection. I'm Dave Yoder, along with Chris Brown. Well, Chris, I think Maryland's headed to a bowl game. We're still talking about football at this point.
No, I've already switched over mentally. I don't even know which one.
You can't skip the Duke's Mayo Bowl for.
Is that who it is?
You can't skip the Duke's Mayo Bowl where Maryland's headed.
It's got Duke in the name, though. So I mean,
yeah, and playing NC State. So, well, put your problems aside.
Oh well, better than not going at all, I guess.
That's right.
What about you guys? Where are you headed?
The Rose Bowl. It's the same as the Mayo Bowl.
We've got more letters in our bowl. So.
Good for you. Well, Chris, as you know, Danfoss makes a number of controllers that concentrate on superheat control of evaporators.
Yep.
Many of these have been talked about this year, and many of these are for case controls in supermarkets and warehouses, but some are dedicated for precision superheat control in applications where you might need some flexibility. And the idea is to control in superheat, but you are controlling a stepper valve on the liquid side of the coil. Yep. Or if you need a controller to send a 0 to 10 volt signal to another control device like a PLC, programmable logic controller, or a ball valve or something like that. So for many years, Danfoss used the EKC 316, the 316A, the EKD 316, and similar controllers as a dedicated superheat controller. And these have all been replaced with the EKE series of controllers, and these have been out there for a couple of years now.
Yep. And they are doing, just to reiterate that part, it's for stepper valves. So, I mean, you get into pulse valves, the AKVs and all that, that would not fall into this category.
That's right. Yep. So, yeah, you're looking at either controlling a stepper valve or using basically the algorithm to control something else with that 0 to 10 volt signal. And now this EKE becomes a valve driver. Mm-hmm. And from what I found, the models are the EKE 1A, 1B, 1C, and 1D. And we'll go into the details of each one of those, but the EKE 1D is a bit of a unicorn because it exists and there's minor differences with that one. But for the most part, we're just going to stick to the EKE 1A, B, and C.
Yeah, I looked at it a little bit last night. It actually had some less features than the C, some that maybe it didn't. So it was like a hybrid between the B and the C, but not one we see much of. It's usually the other three.
Yeah, that's for sure. Yep. So the big picture here is that we're doing superheat control with a bunch of options to kind of fine-tune things. Like, for instance, when it starts up, you can tell it to limit the output of or the opening degree of the valve, or a whole line of other features in there. But when it comes down to it, you have two main options. Like you said, you can use this little controller to do superheat control, or you can use it as a valve driver. And if that's the case, you just run through the wizard and ask you the right questions, and you're pretty much ready to go, pretty short order.
Yep. And so talk about the differences between the A, the B, and the C a little bit. So start with the 1A. So it's kind of like our economy model. So some of the bells and whistles, you're not going to find it here. It doesn't have Modbus on it. It doesn't have a wired CAN bus communication option. Yep. No milliamp option when you're using it as a valve driver. Only the 0 to 10 volt side. And then there's no options for the PT1000s. And so you're talking NTC sensors that you've got to use with the 1A. And I have seen some instances in the past with these where NTCs aren't going to be as accurate as the PT1000s. So if you're looking for something that's very accurate on the temp sensor side, and we're dealing with superheat, so more often than not, that's probably going to be the case. But you maybe want to lean a little bit more towards the 1C, where we'll talk about that in a second, but that's where the PT1000 becomes an option.
Yeah. Okay.
1B, Similar to the 1A, but now you get to add in the Modbus side. So if you need something that's tying back into some higher level controller, whether it's our own system manager or possibly something outside of that, then the 1B would be one of the options where Modbus gets introduced there. And then the 1C is kind of the everything in one unit option, where you get the 0 to 20 or the 4 to 20 milliamp signals that can be used for the valve driver signal. We do now, like I said, have the PT1000 sensor that can be used for that sensor type as an option in the setup. You've got your CAN bus option in there now. So it's really the most common one. And then when we're replacing those EKC models that you were mentioned there to start, the 1C is kind of the default option we go to, just because we know it's going to offer anything that those did as well.
Yep. So the 1C is maybe the Cadillac of the lineup.
As opposed to the Fiat that the 1A is.
That's right. Let's see if we can hear from Italy on that one. Fix it again, Tony. So let's talk about displays on these EKEs. So there is none included. And that's generally for a purpose, because a lot of times if you want a display, you want to make it remote anyway. You can put it on the outside of a cabinet or something like that. But most of the time, there's no one looking at it. So you really don't need to necessarily pay for a display, but you're probably going to need one for setup.
Right.
So yeah, there is none included with these. And the easiest option is to get what we call the MMI GRS2 display. It's a good size display, and you can get a lot of information on it. And it's the most common display, and then you can connect it with just a 6-conductor phone cable. If you crimp the cable the same way on both ends, you're ready to go there. And occasionally there are times when you're doing this display setup that you might plug it in and it doesn't work, but we'll talk about what to do with that. And with the MMI GRS2, when you first plug it in, it has to read a file from the controller, and it takes a few seconds at first, and it'll tell you what's going on. But it'll read that file from the controller, and then it's ready to go. And then if you have to unplug it, plug it back in, it's already got the file, and it'll come up much quicker. Yep. If it doesn't connect, then I think that frustrates some people, because they're not sure where our problem is. And then you just go into the BIOS setup of the display by holding down the X button and the Enter button for about 5 seconds, and then it'll get you into another menu. And when you're in that menu, there's several options, but from what I found, the things to remember are you want to set it for remote application, set it for the CAN communication option for CAN bus, and set it for auto detect.
Yeah, I think I've seen if the baud rate doesn't line up with both of them, that can cause that not to display the information there.
Yep.
And then I wanted to mention also, I think we've talked about CoolProg in the past, maybe with the CC55, if memory serves.
Yep.
But this is also a series, the ABC, that are compatible with CoolProg on a PC. So, I mean, if you're in a spot where that lends itself or makes sense to use CoolProg, the PC-based software there, to maybe set up all your settings so that you can just dump them right in, or say back it up because you're going to be using it multiple times. And just something else to keep in mind there is CoolProg is a tool that's compatible with these EKEs as well.
All right. Do you need the MIKE for that?
Yes, that would still go through the MIKE, just like the CC55s would.
Gotcha.
But same. You could do firmware upgrades of these as well, I believe.
Yep.
So that's, again, just something to keep in the back of your head there. The controllers have a battery backup option, just getting into some of the other features there. So, I mean, if you've got your main power wired to it and that is lost, then the battery backup can be used to close the valve down, so we don't have any flood back concerns. Something that does set these controllers apart, these EKEs versus the prior models, is when Danfoss came out with a series of expansion valves called the Colibri, which are really nice valves. One of the differences in those new Colibri valves was they had a really high current draw to them.
Compared to the old valves?
Yeah, more so than what the EKC 316s and those could handle. So the old valves, I think, were in the 100 milliamp ballpark, and these Colibris are north of 400, maybe up to 600.
Yeah.
I want to say. But the EKEs are designed to be able to handle the current requirements of the Colibri valves. So, if you're going Colibri, you're going to have to use these if you're looking for a superheat controller. Even outside of Danfoss, I haven't seen a lot from other manufacturers that can handle that requirement. So superheat, I mean, these applications, sometimes we're talking maybe a subcooler or a chiller where you might have a solenoid valve ahead of the expansion valve. We know with stepper valves that sometimes they can lose position, they're not calibrated, and sometimes the controllers have options to recalibrate them, but design-wise, people like a layer of safety sometimes with a solenoid ahead of it. So the EKEs are going to offer relays that can be used to control the solenoid valve in addition to the expansion valve itself. And then you can also use a relay for alarming functions if you wanted something hardwired, a light, a buzzer, whatever it might be, to trigger when there's an alarm that the controller generates. Diagrams, I mean, the user guides, the things we offer online for these, you'll see diagrams there that show you where to land the sensors. So you're going to have the normal transducer and temp sensor for the superheat part of the calculation. If you're using it for a valve driver, where the 0 to 10 reference signal goes for that. And so, I mean, diagrams will help you and tell you exactly where everything needs to be wired.
Right. I think you have some flexibility, but there's standards for where everything should get landed.
Yep.
Yep. As far as the pressure transducers, there's quite a bit of variety built into it as far as which transducer you can use with it. And then on the controller, it allows you to power those transducers with either 5 volts or 15 volts DC, which covers quite a range. Yep. And then as far as kind of the start-stop function of the controller, there's DI1 is usually the main switch input. And a lot of times that gets wired to a relay that says, okay, it's time to get going and start controlling. But if you're not going to use that for a start-stop, then you just have to jumper that out.
Yeah, that's an important one. Guys have everything set up right, wired right, and the display just says not running.
Right.
And you say, what the heck's going on here? It's just because that jumper's not in there.
Yep. And there's also a software main switch in the controller too, so you have to pay attention to that.
Yep, just like most of our case controllers.
Right.
And so, I mean, tie this back into a lot of our other podcasts where we're talking about system managers. We've got plenty of applications, jobs, projects out there where the EKE is being used, and good bit of them are valve drivers, but there's also some superheat control. Either way, we when we look at tying these back into an 800 or an 800A, it's going to be through Modbus. So we're using the Modbus plug in the system manager. You've got the Modbus terminals on the EKE. So you're wiring this up through a Modbus communication loop to get it to read on the system manager. You can set an address in it through the display. So through the MMI that you're using for your parameters, you can also use that to set the address of the unit. Each one obviously has to be unique. And you also have to make sure it doesn't share an address if you do have this mixed in with case controllers or leak detectors. Right. It's got to have a separate address from all of that. So just make sure, I mean, outside of that, we're using our normal cable. So it meets the cable requirements we have for a Modbus loop. So EIA 485 rated cable. And that should square you away from a wiring standpoint. I want to say on these also, a lot of times we have to look at the baud rate inside of it and adjust that. It comes 19,200 as a default, and most times to match the baud rate of other devices that are on there, you want to set it to 38,400. So that's something too, especially with the system manager, if you're tying it in there, that we've gotten calls on that. So if you're listening and taking notes, that's one to keep in mind, is you may have to change the baud rate of the EKE, which is going to be a parameter in the setup, change that over from 19,200 to 38,400.
Yep. Got to keep all those baud rates the same.
Yep. Or otherwise it won't come online, and it's another one that's going to have you scratching your head saying, I did everything right. What's going on here?
Yep. Or it'll come online, and then you high five your buddy, and then it goes offline.
Yeah, right.
Yep. All right. So that's a pretty good summary, I think, to get people started. you'll see these used for subcoolers and sometimes heat exchanger control in supermarkets, and then larger valve control in other applications like warehouses and blast freezers and stuff like that. All right, Chris, moving along, it's time for Stump Chris. So I'm going to ask you a question. And
I'm going to fail to answer it. We're going to move on with our life.
I don't know. Feeling generous, it is the holidays after all. So we'll see if you consider these softballs. So I have not shared the question nor the answer with you, obviously, because that would not be any fun, especially for me. But the question today is it involves this controller, and I believe this controller essentially has the valve filter built into it. So you would not be adding a filter to this unit to go between the controller and the valve to boost your, basically how long you can place your valve away from your controller. So what is the recommendation on how long you can make that wire run between the valve you're controlling and this controller? And I'd like the answer in feet, if you don't mind.
Can't go meters on that because that's where my head was.
If you really want to, you can, and I'll convert in my head then.
Oof. I feel like I might be on the underside here. I'm going to say 30 feet.
If you said 30 meters or 30 to 50 meters, I'd say, wow, you're right on.
Okay. I'm trying, yeah.
So, yeah, the main documentation I found is 30 to 50 meters. And I think that's because it incorporates the filter.
Yeah. Was there something in the manual I got in the back of my head that even talks about what cable to use depending on what that length is?
I think you're probably right.
Yeah, okay.
That 84-page manual has a lot of info in there.
Yeah.
Yeah. So I'll take that as a acceptable answer.
Yes.
Now it's driving
my units of measure wrong.
Driving you crazy now.
I can flip the table on you here. There's
You can.
I've got one for you.
Okay, go ahead.
There's an EKE 1P on the market.
Oh, that's right.
Do you know what that one serves purpose-wise?
I've heard about it, but I'm going to say no. What is its purpose in life?
It's basically like the other three options, except it only does valve driver control.
Really?
So no superheat options in it.
So it's reduced price.
Yep. Maybe that's what the P stands for.
P is for price. It's a universal thing around the world.
Yeah. But if somebody's looking for it, if they know they're going in and they're only going to use it for valve driver control, then the 1P is another option there for you.
Okay. That's a added bonus to this podcast.
We got 4 out of 26 letters of the alphabet covered, or 5 if we. Yeah.
That's right. All right. So, how about listener mail? So, this one's for you. And it's going to be a softball, I'm telling you. Comes from a guy named Steve, and I think it's pronounced Venetia, Pennsylvania.
Okay.
Yeah, he said he wants to know what's wrong with the Ravens this year.
You said it was going to be an easy question. No, the offensive coordinator, that is an easy question.
Okay, problem solved.
Yep.
Mix that with a couple injuries, and next thing you know, you're only getting 3 points a game.
There was a social media thing this week where one of the defensive players had a short video clip or a picture of somebody had littered the street with a bunch of flyers that said "Fire Greg Roman." I think he caught a little hot water for recording it, but most of us are on the same page there.
Yeah, well, he'll probably get more hot water than you will for mentioning this on this worldwide podcast.
Of course.
After all. Yeah. All right. Well, thanks for your answer. It's very enlightening. All right. So if you'd like to drop us an email with a suggestion for topics to cover, or a question about anything we've talked about, or a comment, you can email us at controllertalknorthamerica@danfoss.com. That's controllertalknorthamerica@danfoss.com. Thanks for listening. Our studio and video engineer, the man who's doing it all today, is Michael, don't call me Mike Beckerman, and our audio engineer is Raul Garcia. Maria is off vacationing in sunny Romania, and the new guy, Josh, is somewhere out sick today. But he's always going to be the new guy. Until next time, for Chris Brown, I'm Dave Yoder. Stay cool.